The University of Wisconsin-Platteville, in partner with Metal Tech International, presents the Pour'n Pioneers entry for the 2023 Cast and Steel Competition, Project African Spear Point.
We based our design on an Azombo Labala spear point, historically found around the Congo region of Africa. The team enlisted the help of a former student who is now a full-time drafter to kickstart the design process. After creating a 3D model complete with a gating system, we performed simulations with MagnaSoft.
Upon completion of the spear model, an FDM version was then printed. We then made a negative silicone mold of the 3D printed spear point. The team was then able to quickly and efficiently produce wax patterns from the mold. These would later be used in the investment casting process.
After the wax spear point was cast, a sprue was then turned down with the necessary taper for the gating system. Members of the team then traveled to Metal Tech International in Watertown, Wisconsin to attach the wax pattern to the tapered sprues and to complete the shelling process.
The first step in the investment shelling process is to wash the wax molds in a citrus solution to ensure shell adhesion. After washing, the wax molds were immersed in a ceramic slurry. This slurry is designed to finely coat the surface of the wax patterns, and when subsequently coated in stucco, a hard shell layer is produced. This process was repeated 10 times to achieve the desired thickness of the ceramic shell.
Once the steel solidified, the shell material was removed from the castings and sections were taken for metallurgical testing. This testing was used to determine the optimal heat treatment temperatures for our specific alloy. Testing methods used were Rockwell hardness, microstructure imaging, and arc spectrometry.
The last step to finish the spear was grinding and polishing the casting. A portable bandsaw was used to cut the spear from the sprue, followed by a right angle grinder to achieve a rough finish. The spear was then further polished by wet sanding using an orbital sander.
Special thanks to our foundry sponsor and all the individuals for their continued support of the UW Platteville Industrial Studies program.